Hello friends, now we are going to discuss about the synthesis of nanomaterial by using the chemical vapor condensation method. The principle of chemical vapor condensation method is it involves the conversion of metal organic precursors into vapors in a reduced pressure atmosphere and subsequently dissociated by the thermal energy or plasma to generated nuclei. The precursor are transported into the bubbler and then forced into a heated furnace by the helium gas or any other inert gas, where they are later decomposed. The residency time of the precursor in the reactor determines the nature of particles or thin film formed. By adjusting the gas flow rate, pressure difference between the precursor delivery system and main chamber, as well as temperature of the hot wall of the reactor, the prolific production of nanoparticles of the metals ceramic is achieved. The chemical vapor condensation method is a well-known process in which solid is deposited on heated surface via chemical reaction from the vapor or gas phase. In the thermal chemical vapor condensation reaction activated by high temperature above the 900 degrees Celsius. A typical apparatus comprises of the gas supply system and the deposition chamber and exhaust system. The chemical vapor condensation process was developed in Germany in 1994. It involves the pyrolysis of metal organic precursor in reduced pressure atmosphere. A metal organic precursor is introduced in the hot zone of the reactor using mass flow controller. The reactors allow the synthesis of mixtures of nanoparticles of two-phase or dropped nanoparticles by supplying true precursors at the front end of the reactor and coated nanoparticles by supplying second precursor in second stage of the reactors. The process yields the quantities in excess of 20 gram per hour. That means by using the chemical vapor condensation, we can synthesize the nanoparticles 20 gram per hour. The yield can be further improved by enlarging the diameter of a hot wall reactor and mass fluid through the reactor. Here, the process of chemical vapor condensation process, here the precursors are taken in the one furnace and they are heated. Then they are converted into bubblers. These precursor vapors are carried out by the carrier gas. Remember, this carrier gas must be inert gas, and this carrier gas flow with a certain speed, and this carrier gas will carry the precursors vapors and come within the reactant. In the reactor chamber, other reactant is supplied from the other side. Then in this hot furnace, which is kept at 900 degrees Celsius, the reaction will take place and the nanoclusters are formed. By the condensation of these nanoclusters, nanomaterials are formed. These nanomaterials are going to hit the cold finger, which is having the liquid nitrogen gas, in order to cool the nanomaterial. After cooling the nanomaterial, they will get precipitated and those particles are collected in particle collectors. So that here the yield can be increased by enlarging the diameter of the reactant, and we can control the mass of the fluid through the reactor. Here, yield can be controlled by the increasing the diameter of this reactor or by controlling the whatever the mass of the reactant entry here. Then, the residency time of precursors in the reactor determines the nature of particles or film formed. By adjusting the gaseous flow in the reactor, pressure difference between the precursor delivery system and main chamber, as well as temperature of the hot wall of the reactor. Here temperature of the hot wall of the reactor, the prolific production of nanoparticles of metal and ceramic are achieved. The advantage of chemical vapor condensation are it is a simple technique and controllable thickness and morphology. That means we can control the size of the nanoparticles. Application of this chemical vapor condensation method are the mixture of nanoparticles of two phase or doped nanoparticles by supplying true precursor at front and end of the reactor we can obtain. Coated nanoparticles can be also synthesized by using the chemical vapor condensation process.